let's talk a bit about polar versus non-polar. Polar molecules are going to be molecules that have a positive and a negative end. For example, we just drew water's example. Water. We've got the oxygen, and then we've got the hydrogen sides. So it's got a negative end and a positive end. Have you noticed today during this lecture that there's been a bunch I've been saying that I haven't actually written on the board? Like I don't. Yeah, I'm trying to train you to get there. So for instance, these drawings, those of you watching the video, maybe go back and like sketch these into your notes. Huh? So water is a polar molecule. It's got a positive and a negative side. Water it's kind of like, it's got a nickname. It's called the universal solvent. Universal solvent. It's a nickname. It's not true that it's fully universal, but water can dissolve a lot of things. A tremendous amount of things, which is very good and lucky because that is why we live. It's why we need water. It's how we use water. So many things can dissolve into the water in our blood and then move around us. So much of the chemistry in your cells is relying on water's ability to dissolve a huge amount of things. Salts, all sorts of different kinds of salts, proteins, sugars, all these different things. Oxygen, carbon dioxide dissolves into water, all these things. Super, super powerful and important. Good thing we have water. But what about nonpolar things? Well, nonpolar things are materials or molecules that have no separate positive or negative end. They don't, because of that, they're not going to attract water molecules. They're not going to be attracted to them or get attracted by them. They're just not going to interact with the water molecules in the same way.
So basically something didn't dissolve into water, it's non-polar.
It's a good possibility. If it's a good possibility that it's non-polar. So for instance, can you think of something that we know that does not mix well with water? TOP. Oil is, I think, what you're thinking of. TOP and oil are really good examples. Oils. And when you say oils, you're also meaning like fats. Fat molecules are non-polar. Oil molecules are actually a long chain of carbon atoms, and I'm going to go right off the screen, that are attracted, that have hydrogens surrounding them. They're covalently bonded. And remember how oxygen and hydrogen did not share evenly? So the electrons kind of spent more time in one place than the other? In a fat molecule, a fat chain or an oil chain like this, it's a very even share, and so there's no place where there's like more negative than others. So it ends up being kind of neutral the whole way. And so then these water molecules that have like the positive negative thing going on, they actually end up being more attracted to other water molecules. And they just like totally ignore the fat. And they actually, it's like this. Imagine if me, a grown man with a beard, walked into a room full of like really great friends who are all 8th graders. I am the fat molecule. The 8th grade friends are like the water molecules. I walk into the crowd. What are the 8th grade kids going to do?
Run at you.
Are they going to attract me into conversation, or are they going to turn away from me and talk to each other? And all of a sudden, I'm going to be pushed out of those conversation circles, right? Through no fault of my own, and they're not necessarily doing it on purpose, but they're more interested in talking to each other. And I kind of get squeezed out of the group, and then all of a sudden I'll just end up over with the other, maybe if there's more adults in the room, I will naturally end up with those adults, right? And the kids will have like squished me out. That's what happens here. If we have a lot of water molecules, waters are like, hey, buddy, hey, ooh, we're magnetic, yeah. And this guy's like, it just gets squished out in the water.
Use 8th graders.
This course really doesn't like 8th graders.
8th grade is my least favorite year of my entire life. 8th grade sucked.
Same.
Yeah. Yeah, it gets better. It gets better. From wherever you're at, it gets better. Okay, TOP oils are some non-polar. But the interesting thing is, also isopropyl. Isopropyl alcohol is also generally fairly non-polar. It's a spectrum. It's not like perfectly non-polar. It's one of those situations where there's kind of a spectrum going on. Some things are more polar than others. Isopropyl is fairly non-polar. You can dissolve oils into isopropyl or fats into, or you saw you can dissolve the TOP into the isopropyl, right? And what we end up with is we end up with a situation where like dissolves like. So like polar can dissolve polar, and non-polar can dissolve non-polar. Has anyone ever had tree sap fall on a car? Y'all don't own cars yet. Oh, it's a bear. It's awful. Sap is pretty non-polar. And so when you try to use water, the water just like beads and runs right off of the sap and never dissolves it and carries it away. You try to use soap, it doesn't work. What you need to get is like isopropyl alcohol or acetone. Yeah. So you're kind of, it's like,
Is that why?
Isopropyl is probably the best way. It's still a bunch of work because the isopropyl is fairly non-polar, but it's not quite as much. Acetone will dissolve it real quick, but it's not good for the paint.
What can you get acetone?
You can buy that in like, you can go to Home Depot. And you can go, they'll have like acetone cans and paint thinner and isopropyl. They've got all sorts of weird chemicals there. Yeah.
Is that why like wax repels water?
Yes, wax is based on a fatty, oily sort of molecule. And so water will beat up and the water is attracted to itself and not the wax. Remember the paper that we had? The cellulose in the paper?
Mm-hmm.
Polar or non-polar?
No.
Polar.
Polar, it attracted the water. The water ran right up that
Oh
paper.
yeah.
Very interesting. Soap is interesting. Soap has both sides to it. On one end of the soap molecule is a non-polar region, and on the other end is a polar region. Why would it do that?
So it can break up anything.
So it can be attracted to the water, but then also come into your stain and be attracted to your non-polar stain. One common, so things like oil, if you need to get that out of clothes, you'll use a soap. The one end of the soap is attracted to the water, the other end is non-polar. It can hold on to the oil and kind of like carry the oil away as the water pulls it away. Does that make sense?
Yeah.
It's kind of cool.
I think.
Yeah. So you can have some things that can breach this gap, like soap. Down, they get dissolved in the water and go down the drain.
Is it drain in a washing machine?
Yeah.
The water's not just
Have you ever
sitting in
washed a
there.
washing machine wash?
No.
All the water from every wash doesn't just stay in there.
Yeah, obviously your mom
So
doesn't.
then they're like.
Do you have a big giant sink, like a drain
Yeah, I do.
sink?
Yeah.
And then there's like a thing that comes up into that,
Yeah.
and while it's going, it's like,
Yeah.
and you probably have a lint trap on that.
Yeah.
Okay, sorry, let's keep rolling. I got a couple more notes to take. What is solubility? Solubility is, it's a property of substances, and it's the max amount of a substance that can dissolve into a certain amount of solvent. So your solubility is a property of substances, and it's going to be how much of that stuff can you dissolve into a certain amount of solvent. And it's going to be a unique property to each substance. So if you're thinking critically, this might be involved in figuring out between our options from lab today.
Like a measurement of it?
Yeah, we know that our unknown did dissolve in water, and our sodium nitrate did, and so did our sodium chloride, and also our potassium nitrate. It's one of those three. But maybe we could then use they are gonna have like specific amounts that can dissolve into a certain amount of water. So maybe we can compare those and be like, well, 5 grams of potassium nitrate can dissolve in 7 grams of that, but only 4 grams of that. Maybe we can use that. We'll see. Okay, so that's solubility. I want to talk real quick about something else. So solubility, the max amount of substance that can dissolve into a certain amount of solvent. We've got a couple more terms here. Dilute, these should be a review for most folks. Dilute is going to be like called like weak solution. It's got less solute, a lower amount of solute. It's like a weak solution. Concentrated, well, that's going to be like maybe a strong. We call it a strong solution. It's got more solute. It's, there's a lot more poured in there. But then the term that I really need you to know is saturated. And a saturated solution has maxed out the amount of solute that can possibly dissolve in there. If this is a saturated solution of copper sulfate, if I add one more crystal of copper sulfate and I stir and stir and stir and stir, what's going to happen to that crystal?
It's just gonna stay there.
It's just going to sit right there on the bottom. Because the solution is full up. It can't take any more. We're going to play around with this saturation point, and we're going to see some things that can affect the saturation point when we come back to class on Tuesday. Thank you very much, everybody. I'll leave that up to you to finish your notes.